Assalamualaikum and a very good day to everyone. My name is Siti Fazila Nur Ain binti Sidi Omar, student of University Teknologi Mara Shah Alam, program code EE750. We present to you computational analysis and optimization of thermoelectric performance, investigating of thermoelectric materials through simulation techniques. Research summary. Global population growth and rapid pace of industrialization is increasing, therefore facing energy supply depletion and environmental populations. Thermoelectric have been widely investigated as clean energy conversion technology. Thermoelectric has the problem of low efficiency and exactly low value. Bismuth telluride is a common thermoelectric material because it has the best figure of merit. However, this material is not resistant to high temperature and high toxicity. So another material, which is oxide perovskite, is becoming more critical as have been found to have a high temperature durability, non-toxic and environmentally benign nature. This is some of the literature review that was done in this research. And finding in the literature review is first, bismuth telluride is widely used in the industry. However, again, this material is not resistant to high temperature as other material. Second is, perovskite is inexpensive to manufacture, use non-toxic ingredient, and is readily available. They have excellent thermal and chemical resilience at elevated temperature. The problem in this research is bismuth is the best present day of material for application at low to medium temperature. However, this material has specific problems such as poor thermal durability, high toxic and high material costs. And bismuth are readily oxidized and vaporized. They cannot be used in high temperature applications. Next is bismuth and tellurium is low abundance in the earth crust and in ocean, also become problem for the manufacturer. And the period of time between discovery of the material and the production of industrial model is very long. So the objective of this research was, the first one is to analyze the electronic and thermoelectric property of oxide perovskites, such as strontium titanate and COMSOL, and the second objective is to express the ability and the possibility of a credible thermoelectric material in terms of figure of merit. The scope of the study is we are going to be using COMSOL Multiphysics, which will be used to simulate two different thermoelectric materials, which are COMSOL and strontium titanate, and will be compared with the common thermoelectric material bismuth telluride. Two different thermoelectric effects will be studied also, which is the Peltier effect and the Seebeck effect, which the input data are different with each effect. Research methodology. So for the material, as mentioned above, we're using three: thermoelectric, which is bismuth telluride, COMSOL, and strontium titanate. The simulation will be carried in a steady state environment. All materials are linear elastic, and all materials are available in the COMSOL Multiphysics software described in the literature. So in the geometry conceptual, there are going to be two single leg and a single thermocouple. So the geometry model was built in the COMSOL Multiphysics software. The meshing is different for the single leg and single thermocouple. The mesh is determined using the sweep mesh approach. The meshing pattern of the geometry was manually specified to increase the accuracy and save calculation time. So for the input data for single leg and single thermocouples, for Peltier effect, we're gonna introduce 0.7 ampere of current at the top of the leg, and at the below will be grounded with 0 volts, and we'll introduce a temperature of 273.15 Kelvin. And for the Seebeck, two different temperature will be introduced on the top and the bottom of the lake, and still be grounded at the bottom. and the single thermocouple for the Seebeck effect to the same two different temperature will be introduced. Data collection and analysis for the single leg Peltier effect. First is temperature distribution. As you can see, the strengthened ternate and COMSOL show heat effect, while the bismuth show a cooling effect. For the electrical distribution, both the perovskite produce a higher voltage to drive 0.7 ampere. This is due to the higher electrical conductivity of the perovskite material. Variation of thermoelectric legs. So the temperature distribution, the temperature difference of the thermoelectric for both material increase with increasing of height. The temperature of COMSOL produce a higher than the strengthened titanate due to difference of the thermal conductivity and internal resistance of each material. The electrical distribution both have a linear increment, and as the height of the TE leg increase, the voltage output also increases. The data collection, as you can see, single leg Seebeck effect for the temperature distribution, bismuth telluride show a faster increment of temperature compared to the both perovskites. And the electrical distribution, strengthened titanate produce a higher voltage than the bismuth and the COMSOL. For the single thermocouple Seebeck effect, the temperature distribution is different each material. Bismuth telluride show a higher thermal conductivity. They show a smaller temperature gradient resulting in a low percentage of thermoelectric converted energy. And the power output is strengthened titanate has a higher power output compared to the bismuth and the COMSOL. Power increase with increase in temperature difference, thus is open up the possibility using material in higher temperature of TEG. So status of data collection and analysis. So data collection for the single leg Peltier, Seebeck, optimization of leg height and single thermocouple, result is 100%, analysis also 100%. List of publication, 3 publications have been made. Only the effect of thermoelectric is being accepted with minor. For the status of thesis writing, so introduction to review research methodology is 100%, result and discussion 85%, while conclusion is 90%. Total of word count is 10,334. Future work completion of thesis LOI form already been submitted. Thank you. That's all.